Question 5, just a video for that one alone. Question 5, page 114. Janet has a rectangular pond in her back garden. There it is, it's a 1 by 2 meter pond. She wants to make a rectangular concrete path around the pond, and it's got to be X meters wide in all directions. So all these little lengths here are X's. Alright, there it is. She wants to know how the area of the concrete path changes as the width X gets bigger and bigger. Clearly, as X gets bigger, there's more concrete around the edges of the pond, so that's clearly going to be a bigger area. So we've got to write a formula now for the area Y when you know the width X. I've got my X and Y ready to go later on. So let's have a look here. Well, X times X, well, that's X squared, isn't it? This part will also be X squared. This will be X squared, and X times X, X squared. So I've got 4 little squares in the corner. Here I've got 2 meters by X, so that's called 2X. 2 meters times X here. This part will be 2X meters squared in area. And here I've got X times 1, in other words X square meters, and X times 1, X square meters. So essentially I've got 1, 2, 3, I've got 4X squareds, and I've got 1, 2, 3, 4, 5, 6 Y's. Sorry, not 6 Y's, 6 X's. And that gives me the formula for Y equals the area of the concrete path. So altogether then, Y equals 4X squared plus 6X meters squares worth of area. Alright? Draw a table of values for X ranging from 0 to 5. Alright then, so 0, 1, 2, 3, 4 and 5. Well, we just substitute each of these X values into this formula. Well, clearly if you put 0 where the X is, you have no area whatsoever. Put 1 inside there, 1 ones is 1, 4 ones, so it's 4, plus 6 times 1 is 6, altogether 10 meters squares of area. Substitute 2 into there, 2 squared is 4, 4 4s are 16, 2 2s are 12, 16 and 12, 28, etc. Let's just demonstrate this one. So Y equals 4 lots of 3 squared plus 6 lots of 3. That's 4 lots of 9. Clearly, 3 squared is 9 plus 18. Altogether, 36 plus 18 comes to 54. And 54 goes there. I don't need to demonstrate 4, I just take it straight from me previously worked answers. If you substitute 4 into the formula, get an area of 88 meters squares. And similarly, if you substitute the 5 in there, you get 130 meters squares. So there you go, I've demonstrated one and I've done 2 or 3 in my head for you. Now, draw a table of values, done it there. Therefore I've got these coordinates here, 0, 0, 1, 10, 2, 28, etc. You don't really need to do this in an exam, but I'm just showing you that what we've generated is a set of coordinates from the table of values. Now I can draw a graph showing how the area changes as the width gets bigger and bigger. So Y is the area we've calculated, and X is what they call the width of the path. So I put the word width up there, and of course this will be in meters squares, it's an area, and we're told that X, the width, is measured in meters anyway. And here is a lovely graph, or rather a grid I produced earlier. So let's get plotting, shall we? 0, 0. Well, that's that one. Obviously if you've got no width whatsoever, you don't have any area. And then we go 1, 10. So 1 along, 10 up. Then we go to 28. That's 20. 28 will be 1 square below the 30. Then we're going to go 354. So 350, 60, 54 will be 2 squares up. I'll make it about that. Then I'm going to go 488, which is just 1 little square below the 90, and 530, because I remember that one. 530, that's a lovely little curve going up. There we go. So as X gets bigger, Y gets even bigger in terms of the area. Let's try draw a lovely little curve. I'll try and do that anyway. Right, let's have a little bit of a run up. It's always difficult, really hard on. Oh, missed it. I think, oh, that'll do. I'll give you, if you did that, I'll definitely give you the mark. Right, let's answer the odd question now. It says, Oops, went too far. Right, it says, what is the area, in other words the y, if the path is 1.5 meters wide? So going over to 1.5, using this facility here. So 1.5 is there, and then just turn left. Well, from my graph I make that exactly 20. Well, as you can see, I've gone a little bit higher there with my I think it's just a little, should be a little bit lower, shouldn't it? I've missed the point there. But anyway, from my graph, it's the best I can do at the moment. From my graph, I've gone up there, turn left, and I make mine about 20. So put the answer down there. What is the area? 20 meters squared. And now what is the width of the path? Well, I've got an area of 25. Okay, so 25 meters squares. Let's just change colour so it stands out a little bit. So 25 meters squares on this axis. I wish they asked us for a nice bigger area and make life a lot easier. Makes this almost redundant, doesn't it? Anyway, 25 meters squares between 20 and 30. Plant it there. Again, this is really rough. Do the best job we can, really. Stick it about there. Show the examiner what we're doing. We went across to the right, then down to the left. That's going to be, let's have a look. I'm going to say that's 1.8 meters. It's about 2 squares away from 2, so it's 1.8 meters. So that's what I'm going to stick to anyway. So what is the width of the path when the concrete has an area of 25 meter squares? I make that a width of 1.8 meters in length. And I'm going to stop there and then look at other little videos. Maybe one video per question, depends on how complicated the situation is. So that was the graph we generated, and we actually read off the graph again. Lovely graph. We should have been able to use some of this really, but we hadn't. Never mind. So we'll stick to that, and I think I'll save it as is, and I'll catch you quite soon.